All right, with this, we're going to jump right into our next interview for the day, and that is bringing on Joe from Aztec. Joe is one of the co-founders of Aztec, and we're going to talk about the importance of privacy and bringing it on chain. So please join me in welcoming Joe on stage.
Sure. Thank you. Hey, everyone.
All right. Joe, I've known you for over 6 years now, and
I think this is our eighth ETH Global.
This might be probably more. Since then, the only thing I've known that I know you definitely like is privacy and Ethereum. So that's been very consistent. So my first question there is, well, let's just go into why. Why do you think privacy is important, and how do we actually make that relevant for crypto?
Yeah, it's a good question. I think starting with kind of looking at the world around us today, like we're in London, financial hub of the world, and we get pretty used to the privacy we enjoy in our like daily lives when we pay someone, when we pay the tube, when we get here. And kind of when you look at that, there is privacy in everything we do. And then you start to look at Ethereum, you go on Etherscan, and that privacy just doesn't exist. You can see every historic and future transaction from any blockchain address. You can see their balances, and that world's pretty scary. So we care a lot about privacy at Aztec, because if we're going to build these new payment rails for the world, I think we at least need to do as well as we did with the traditional banking system, and that was a pretty low bar. Like we in the traditional world trust a service provider with all our data. That service provider usually sells it to someone, but we get some privacy. So at Aztec, we care about onboarding kind of billions of people onto blockchain and giving them hopefully better privacy, not worse than we have in the Web 2 world. So that's kind of, it's been our mission for 5-6 years now, and we're getting pretty close to delivering on it. So yeah, excited to be here.
Nice. One kind of common thing that we hear all the time is that there's a misconception that when people hear the word ZK, they think it's just everything is private, and that's definitely not the case. Could you kind of clarify what is a good intuition around it, and then kind of then zooming out, well, what is Aztec and what are you building?
Yeah, I think this is some good marketing on some of the other L2's parts. So ZK is usually kind of an abbreviation for zero-knowledge proof, and specifically ZK Snark. And there's two interesting properties to ZK Snarks or Starks that we care about. One of them is succinctness, and this is kind of proof of computation. And you can use that to, instead of having Ethereum verify hundreds of thousands of transactions or 50 million transactions in Stanley's case, you can just have a proof that those were executed correctly. And a lot of ZK teams are using that to scale Ethereum and get higher throughput kind of L2s. The other interesting property that's kind of somewhat forgotten is zero knowledge of these ZK Snark proving systems. And you can use that to encrypt information and hide data. And so at Aztec, we're kind of using both properties, and one of the only roll-ups to actually be doing this, but we use the zero knowledge property to encrypt information and kind of hide your resultant state of a transaction. And we can get into more on that in a second, but at a high level, we're building a privacy-focused L2 on Ethereum that has public and private state that's composable.
So let's get more into that. So you're leveraging those two properties, but just to confirm, it's not the same as a ZK-EVM as well either. Is that right?
Yeah, it's not. So if you look at like the EVM, it's a great virtual machine, but it has some flaws. Like there's no privacy built into it, so we can't take the EVM and actually use that to give developers private states or private function calls. So we have a different architecture. We have what we call a kernel circuit, which allows users to run transactions on their own device, create a proof on their local device, a bit like end-to-end encrypting in Signal and messaging apps. But in this case, you're running arbitrary code on your device and proving its execution. And then that's paired with what we call the Aztec virtual machine, which is it's just another virtual machine that's a bit more like Starknet or Cairo that has extra features that make it easier to interact with the private state. And so the two together are the kind of Aztec execution environment. And we took the view quite early on that trying to add privacy to the EVM was kind of a fool's errand because it just wasn't designed for that.
Why?
Yeah, I guess, well, on a fundamental level, like if you think about how a blockchain works, you send a transaction to a public mempool, and in order for the other nodes to validate it, all the data needs to be public. So you can't take that virtual machine and keep the properties of strong consensus and also get privacy. Some people are trying to do it with kind of FHE and other things like that, but it's many years off. So yeah, we had to kind of start from zero and work out a new type of execution environment that would allow privacy to be built into these applications. But we still do benefit from the consensus of Ethereum. So we're very much a roll-up on Ethereum. We inherit all its security properties. We get the best bits of what Ethereum offers, but with just a different execution environment.
So this is super interesting. So obviously a big piece of being able to validate things at scale and kind of keeping it decentralized and open source is that everybody can kind of verify that the same information is there. But if everything is encrypted, how do you kind of get the same guarantees? And more specifically, does something change in this manner where you're trying to access private information? Because yes, I may not want to publicize how much money I have in my wallet, but what about me interacting with a DeFi protocol that's on Aztec? Does it not need to know how to read things? Can it read everything just the way it would? Are there any gotchas? How do we think about that world?
Yeah, so there are some different mental models, I think, when you're dealing with private state and private execution. I think the first one that's worth touching on is that someone or a group of people needs to own private state. And what I mean by own is it's encrypted for a given key. That could be a shared key between lots of different people, but it belongs to someone. And then you have like public state, which is obviously global and anyone can see it. And usually the flow of a transaction in Aztec is there's kind of a setup phase where you want to do something that's hiding information. It could be hiding your passport, proving you have a UK passport inside the pre-part of the transaction, the private part. And then that's like the gateway into maybe a more public execution like an AMM. So it's, for developers, kind of you have the best of both worlds. Some things like AMM designs just need public state. You need a shared global variable to exist. But the best thing about Aztec is you can choose what's public and what's private to get the best of both worlds. So I think the first mental model that I would flag is that private state usually needs to be owned by someone. And then I think the other thing that's a little bit different when you're talking about privacy or private execution, we sometimes call it, is where it's running. So in the kind of traditional blockchain model, you send a signature to a mempool that kind of outlines your transaction request, and someone else does the computation. On Ethereum, the block builder will do the computation. On kind of public L2s, the builder will do the computation and someone else will prove it's done correctly. But on Aztec, for the private portion, the user is doing the computation and they're proving they did it correctly with a ZK snark. And this has an interesting property that you get unlimited runtime. You have no concept of gas in a private transaction because if you can make a proof, you can do whatever you want in that transaction. You can also feed whatever data you want into that transaction. So you don't need to just be constrained by data that's on the Aztec blockchain. You could feed in health records. You could feed in kind of all your bank balances that were in like a signed CSV, prove some computation over that, and then do some resultant state. So there's a lot of like pre-setup that happens in the private land, and then my mental model is you then go and do something with that, maybe in the public DeFi land.
Oh, super interesting. But I guess to do now, effectively kind of having this decision to decide if it's a private versus public side of things, you need different primitives, and you've had to invent a new programming language called Noir. What is kind of the current state of Noir right now, and how's the development of the language going?
Yeah, so we've been building Noir for about 2 or 3 years now. It started with a grant from the Ethereum Foundation, and so Noir is this low-level language or mid-level language for writing zero-knowledge proofs. And on Aztec, all of our contracts are written in Noir, but there's some libraries which help you kind of write public functions or private functions. So to the developer's point of view, you just write one contract and you tag which functions are private and which functions are public. So you don't have to think about these two different execution environments when you're writing code. It's a very seamless kind of composable developer experience. Noir's in a pretty good state right now. You can already do things like, as I said earlier, prove you have a passport. You can like read the passport with your NFC chip and then prove that the signature inside it is pretty performant. We focused a lot on the DevX, so it has the exact same syntax as Rust. So if you like Rust, you'll like Noir. And also kind of just getting started is quite easy. We have a lot of code spaces on GitHub. If you've ever used a code space, you just click a button and you get thrown into kind of a web.
Just literally Visual Studio Online.
Yeah, Visual Studio Online. We've got a great, what's it called? Like an IDE plugin that does syntax highlighting, does like go to definition. So it's very easy to actually get started with Noir. I'd say it's in beta stage, but still pre-audit. Audits this year.
Awesome. A couple more things I want to ask before we wrap up. You have been a product person your entire career, and the thing I'm curious about is when we kind of see all these things that we have to address in this new paradigm, especially when you introduce a notion of public and private data and giving people a choice, how do you actually make that seamless? And what have you been thinking about or have done so far in terms of actually making that on-chain experience seamless?
Yeah, I think it starts with like the developer environment. So you have the Noir code space, which is like, I just want to mess around with like a little Noir program, but we have the same thing for developing on Aztec. So if you want to write test contracts in our Aztec Sandbox, there's also a code space. So you don't need to kind of waste 3 hours installing the right Docker dependencies or making sure you've got the right version of Node to get going. You can get going in a browser. And I know ETH Global has good Wi-Fi usually, but you don't have to deal with Hackathon Wi-Fi because it's running on a remote server. So I think there's some like low-level primitives which just help developers on board. And then once they're kind of in and they've decided they want to invest 3 hours, I think having kind of sensible defaults so that they don't have to reinvent the wheel. So we have token standards, so you can do basic things like transfer tokens, and you can kind of build around this like ecosystem of quite good primitives to actually get to what you wanted to do rather than having to reinvent everything. So I think it's a combination of sensible defaults and just good DevX that we focused on initially. We haven't got it all right, so we are iterating quite a lot, and we have prizes at the hackathon. So if you guys have any feedback, we'll take it into account.
What about being on-chain on the UX side of just kind of the web experience? So you kind of said, hey, people have to now create the proofs on their computers now. Does that mean like I can't do something because my computer's not powerful enough, or I have to like now wait a couple minutes to do some confirmation or a basic thing? How do we kind of simplify that experience?
Yeah, so Noir is kind of the language you write your programs in, but under the hood, what actually happens is you plug into a cryptographic backend, and most developers don't need to worry about this, but effectively Noir abstracts the cryptography from developers. And what we've been hard at work on at Aztec is ensuring that cryptographic backend is performant enough. And so this technology is not going to get adopted if there's a noticeable UX trade-off for constructing a proof. So we've set some pretty ambitious benchmarks of being able to construct pretty complex Aztec transactions, like 6 smart contract calls on a phone in under 30 seconds. And that's kind of like the most complicated DeFi transaction.
That's awesome.
You can think of. A basic payment should be under a couple of seconds. So inside that, you get full account abstraction. You don't have to deal with kind of Ethereum keys or seed phrases anymore. You can use Touch ID as a signature. So we spend a lot of work under the hood building a proving system that can deliver all of this performance. And I guess developers now just need to build the applications that make it useful.
Nice. Well, kind of the last thing I want to ask you here is there's been a handful of bold announcements by the Aztec team. So I guess I'm curious about getting an update on where things are headed and what's next on the Aztec roadmap.
Yeah, it's a good question. So we launched our kind of initial v0.1 sandbox back in September, and we've been kind of iterating on that for probably the last 3-4 months. It's approaching kind of feature completion, so it's getting a lot more stable these days, and that's what you can hack on today at the hackathon. There's docs on our docs.aztec.network site, and you can kind of get a flavor for all of the types of applications you can build on Aztec with that sandbox. It's like a local Geth node, basically, but for Aztec. And so from here, our kind of engineering roadmap is trying to get everything working end to end. So we've got this sandbox environment, but actually, can we make it construct full proofs? Can we build a full roll-up on a testnet? So we'll kind of heads down. Our office is kind of a mile from here, trying to get that working over the next kind of month or two. And once we've got that working, we'll start to kind of plot out a path to a decentralized testnet. At the moment, we're kind of focusing on just the network side of it. So the sequencing infrastructure, the peer-to-peer transaction pool on Aztec. And then maybe in Q3, we'll have a full developer testnet for everyone to kind of play with.
Awesome. That's very close. Q3.
Yeah.
We're at Q2 in 2 weeks.
Time's flying.
Pressure's on.
Yeah.
Well, Joe, thank you so much for this amazing conversation, and can't wait to see the public testnet for Aztec in Q3.
Awesome. Thanks, Kartik.
Appreciate it. Yes.